Hello, my name is Jeff Williams, and this is my final project for BA 513 Contemporary Analytics. Today, we will be looking at Spotify subscriber churn and creating a model to predict if Spotify subscribers will continue their subscriptions or choose to cancel. For my professional life, this is very near and dear to me. I work for a software as a service company called SAP Concur. So subscription revenue is supremely important to us, and revenue under management for that matter as well. So you want to make sure that you have your subscribers on hold and you are meeting their needs. So I'm excited to have this model explore a little bit of what's important to subscribers, why they might choose to leave, or what impacts that decision making. As far as an agenda for today, we're going to take a look at the business problem and understanding the why behind this project and what makes churn so important, or why we might need to have that be top of mind in the subscription business. From there, we'll go to a little bit more of preparing for our model, the data understanding, where did we get this data, and what impact it could make on our model itself. From there, we'll actually prepare that data and make a feature selection for the model to ensure that we're testing everything as needed. We'll actually develop the model from there. I chose a logistic regression as a sneak peek for our initial model. And then from there, we'll evaluate that model, interpret how it performed against other models as well. And then finally, we'll take a look at the results and see if we're ready for deployment. And then at the end, I'll have our conclusion and give you a little bit of insight on my takeaways from the project as a whole. So I'm excited to jump in. Let's go ahead and take a look at our business problem and understanding today. So predictable revenue was something that is often seen top of mind for any company, but in the subscription business, predictable, steady income allows for better planning and investment and growth strategies, honestly. So high churn rates undermine this predictability, making it difficult for businesses to forecast revenue and to allocate resources effectively. And there's also customer acquisition costs that come with churn. Acquiring new customers often can be way more expensive than retaining old customers. When a business faces high churn, it means the business must incur expenses to replace customers that it loses, and it can eat into the business's profits, especially if the churn rate surpasses the rate of customer acquisition. In this case, I think of things like marketing costs or additional costs in driving new features to bring people to the platform. Lifetime value is also very important. This is the total revenue that a business can reasonably expect from a single customer account. So high churn decreases that lifetime value because customers aren't sticking around long enough to make subsequent purchases or to renew their subscriptions. Brand reputation is also going to be very important in churn. Online reviews and word of mouth play a significant role in customers' minds and their purchasing decisions. Consistent negative feedback or perception that a company are leaving or customers are leaving a company's service can deter potential new subscribers as well. For businesses seeking external investment, a low churn rate is also going to be very important for this investor confidence that they'll see. So while a high churn rate can raise flags for investors as well. So our goal is always going to be to keep that low, so investors have a very good understanding this business is healthy and they can feel confident investing their money. For Spotify being a public company, this is supremely important. They do want that stock price to rise. And obviously they have a lot of market share currently, so they want to continue to hold that market share and to grow their share price over time. And we can pivot into the data collection, what this looked like for Spotify and for this model. In this case, I am using a synthetic data set that I got and was approved for the course. There are 8,000 examples in this data set and 12 attributes. So things like your user ID, telling us which listener we're actually evaluating, their gender, the age, which country they were listening in. Also things like their subscription type, whether that be a family subscription, a premium subscription, or maybe a discounted subscription like the student. And then we also do have free listeners included in here as well. Listening time, this is how long they decided to listen to music for. We also have the number of songs played by a user. The skip rate is a ratio giving us some detail into how often they are skipping and maybe how the algorithm is performing in their case. Ads listened for our free tier. How often are they listening to ads and how many did they listen to? Offline listening was also included in this data set. I will call out that I did remove this attribute prior to doing the model. This was removed due to a lack of clarity on the data sets. The 0 and 1, it was not clear which one was true or false. So that was removed prior. So that might eat into our data preparation just a little bit there. And then finally, we also has is churned, which is our target variable for today. As far as data preparation was concerned in AI Studio and making these feature selections, first thing was first was setting some roles. I have 2 attribute roles that I needed to set for this model. Those being the user ID. I do not want the ID to be included as it's not pertinent for the model itself. So that is being set to the ID role and will not be used in the model. And then also, just as I mentioned, is churned is our target variable. So I did set it with the attribute role for this model itself. And finally, or I shouldn't say finally, I suppose, the nominal to numerical, I also made some changes there. So we converted 4 attributes. Those are converting country, device type, gender, subscription type, all to numerical values. So all those were changed. I made those updates. And within those groups, I also chose 4 comparison groups as well. I chose male for the gender, desktop for the device type, free for the subscription type, and US users for the numerical values. And then finally, the last step was just to convert is churned to true and false for the model's use. So that's what it looked like setting up the data. Nothing too crazy on this end. We just want to make sure we're putting us in a position to win and that the models can perform as needed. And then in here, I also did split the data as well. So I went with a 70% to 30% ratio. My training set is being the 70%. That is 5,600 examples. While the testing set, what we'll actually be utilizing will be 30% or 2,400 examples in this case. And now we're ready to get our model going with and do the development. Our logistic regression is what I chose today. I wanted to see the p-values, our significant attributes, and also I feel very comfortable using this as a start, and we can evaluate against more models further. I also use apply model for the testing data using that 30%, the logistic regression, of course, utilizing the training data with that 70% split. And then I also have performance on here just to give us benchmarks on how well the model actually performs itself. So we'll see all of those being utilized in this. And I can go ahead and jump forward here into our model evaluation and interpretation. As far as the results, when we hit run on that model, we found 2 significant attributes. So skip rate, that ratio we talked about earlier. How well is the algorithm performing for users? Higher skip rates resulted in more churn in this case. And then we also do have subscription type as 2. Subscription type as well. Family and premium subscriptions are the ones that were significant attributes. So I did think that was interesting. Seeing that customers that are paying the full amount either for themselves or for their family are the ones that are sticking with the subscriptions. And the student plan actually was not a significant attribute in this case. So discounted subscription, something to keep in the back of our mind for the future. Overall, the model performed with fairly low confidence. The most confident prediction that it made had an 82.8% prediction confidence. And sadly, this resulted in an incorrect prediction. So you can see on our top line there, row 1608, we predicted false for is churned, and it was true. So that was fairly disappointing to see low confidence in the model. In previous models I've executed in this course, I've seen upwards of 90 to 95% confidence, or I suppose as the most confident prediction. So that was a little disappointing to see on my end. And sadly, the story didn't get much better from there. We also had very poor accuracy just in general throughout the model itself. So we saw 27.15% accuracy, and also in this case predicting true on 1,736 false examples. So a distinct lack of confidence, poor accuracy to this point. After seeing these numbers, I decided it was time to run a ROC comparison. I wanted to get in and see what other models would perform like, to see if it was the data set, if it was the model, what changes could potentially be made. In this case, the ROC comparison, I used 5 different models, including logistic regression kind of as our base. Included that still, but also including things like decision tree, random forest, deep learning. And we didn't really see a lot of changes in the results. So a pretty poor showing, sadly, in this case. And as far as the model results and deployment are concerned, obviously, we've been talking about the low confidence, that 27% accuracy, and in general, really lacking significant attributes, only seeing 2 attributes. And from there, only a couple of the comparison groups being significant as well. In this case, I would say at this time, I would recommend to not deploy this model. I do think there is a lot of potential for the model. And I suppose, and with that being said, my conclusion is that this case study highlights both the potential and the challenges of churn prediction, and that for those subscription model businesses. Although the models perform poorly, I believe this exercise highlights the important drivers of churn, like algorithm success, impacting skip rate, and value found from customers paying full price subscriptions. While also this case study sets a foundation for more advanced modeling. For Spotify, I'd say the next step is to refine data inputs. So I would definitely focus more on those paying customers in the future, and then also finding more ways that the algorithm is making an impact on people. And I would build more sophisticated techniques to build retention strategies from there. So I do think that there is a lot to learn from this model, but sadly for this moment, I would not deploy it. And I would say that this can be utilized as a building block or a foundation for future modeling. But thank you all so much for listening. I really enjoyed this project. I was sad to see it not be as confident or accurate as I had hoped, but I'm excited about what this could lead to in the future, and also how I can build on this in my future modeling for especially things like my business at SAP Concur. So thank you all so much for listening once more. I appreciate it.